You can see all tutorials to StatCrunch. This is tutorial from the school, but I will record my own for homework. As I record it, I will do specifically your homework related StatCrunch topics. Okay? Um, in the case of, if you click on assignment, what you're gonna have here you have all assignments at once, and quiz and homework and test. All right, those are past due. Wait a minute, 1.2, 2.1. I thought I fixed it. It didn't save it. Looks like I have to fix it again. No, not a big deal. Okay, so, and that's all. So let's start working on first homework, section 1.1. Okay, let's see what we have. So what is the definition of statistics? It's gonna change your answer, so it's gonna be something similar. What is the statistics is about? Statistics is a science that study, that collect the data and then organizing data, because when you are cleaning the weeds, right? When you are working in the yard, you clean the weeds to allow the good stuff grow. The same thing is here. So when we collect that data, you have to look what you need, what you don't need. So you just kind of clean out. So that's what it is. You collect the data, organize, that's what it is, and then do analysis over the data that you get, and conclude, do interpretation based on collected data. So, which means the answer here is gonna be this one. Okay? Next. I'm going to submit right away. Bingo, correct. Next one. Question number 2. What do we have here? What is the right answer below about in which of the following are important in statistical thinking? So first one, getting data from entire population. Yes, it is important, of course. Using individual to make prediction about, using an individual to make prediction about population. You don't use one individual. It's gonna be entire sample about population, meaning the group from population, because you cannot test the entire population. It can be too large. By the way, the students who are interested to listen the lecture, you can watch the lecture in the module under the same chapter 1.1, and or you can go to YouTube channel, find my YouTube channel. I can post the link. It's statistics _ lecture playlist. Okay, and you can watch everything about population and sample. Okay, next, being 100% correct. One thing you need to know, statistics is never 100% correct. Maximum it can be 99.7%. It's never gonna be 99.9% even, but not correct 100%. So next, designing a study that will replicate. It's of course important, but for statistical thinking, the most important is controlling for sampling or non-sampling error. This is the most important focus on for statisticians, because if you lower the error, the higher is your confidence, right? So people, statisticians, scientists are working on reducing error, because once they reduce error, they automatically will increase the effectiveness of work. Okay? Right? Question number 3. What do we have here? So determine whether the variable given is qualitative, quantitative discrete, or quantitative continuous. So let's understand what is qualitative, quantitative, and quantitative discrete or quantitative continuous. So first of all, the qualitative, those are the subjects that represented quality, represent the quality. Okay, thick, thin, I don't know, white, blue, water. Those are things you cannot count. So those are qualitative. Quantitative, discrete, that you can count. They are discrete and they represent quantity you can count. But quantitative, continuous, that you can the measure, you can count it, but it still doesn't represent discrete because it is continuous. Okay, so in this case where we have thickness of aluminum can, thickness, it is you can measure, right? It's a quantitative, but at the same time thickness is a continuous, right? You can't it's not discrete, you can't count anyhow the thickness, right? So which means this is gonna be, in this case we have two cases, quantitative, this one, and this one. Let's see which one is gonna be. Quantitative continuous, since this variable would yield number that measure, and the other one, a quantitative continuous, since this variable would yield numbers that count. As we said, there is nothing to count about thickness, right? Therefore, it's going to be measurement, right? Quantitative continuous, since the variable would yield number that measure. Thickness we can measure, but not count. Therefore, this is going to be the answer. Okay, and here you have see small icon about video. You can click and watch the video about it. Okay. Question number 4. What do we have here? Determine whether the variable given is qualitative, quantitative discrete, or quantitative continuous. Number of points scored on an exam. Okay. Well, number of points scored on an exam. Well, first of all, we can say it is quantitative, correct? Because taking number of points you can collect, right? You can count it. And that is score, you also can count, correct? This is going to be quantitative. Let's see, quantitative discrete, which one? Either this or this. Variable would yield numbers that count. Okay, I would say this one. The other one, quantitative discrete, since variable would yield number that measure. We don't measure here, we count it. Yes? Bingo. Next one, determine if the following example, if the following is an example of descriptive inferential statistics. Okay. So what is descriptive? What is inferential statistics? Again, I'm going to send you the link to my lecture so you can watch it. Find there in the inferential and descriptive statistics. At the same time, you can watch on your video of the lecture once you click on module, and there is a video for your lecture for this chapter 1.1. Every chapter you're going to do homework, I will recommend click that the chapter, be it in assignment, be it in module, not in assignment. In assignment, you will find only homework, but if you click in module, the chapter 1.1, you will find their video lecture. Okay, descriptive and or inferential statistics. Let me explain real quick. Statistics has two branches: descriptive and differential. Inferential, sorry. Descriptive statistics is the one that collect the data, organize data, and analyze data. And then passing to inferential statistics, that is gonna make sense out of information is given by descriptive statistics, meaning draw conclusion. Okay? So let's read the question. A survey was done asking 300 students how old they are. A histogram was produced to display the result of the survey. Well, does it make sense, this topic? What does it do? It just build the histogram, collect the data, information, and build the histogram, right? It's definitely going to be descriptive statistics. To become inferential statistics, we would say that they drew conclusion, or that means that blah blah blah. That would be inferential. So they draw the conclusion. But here it's just telling you steps what they did. So this is going to be descriptive statistics. Okay. Question number 6. In a study, the data you collect is weight in grams. What is the level of measurement? Here I'm going to explain to you level of measurement. Nominal, ordinal, interval, ratio. And I will post the link to my lecture besides of the video you will have in your module 1, chapter 1.1. So nominal, ordinal, they have similarity. Interval, ratio, they have similarity. Let me explain. Nominal, it's a type of measurement where you can't count. It can be color. It's a qualitative data. Let me put a short version. Qualitative data that you cannot count. Yellow, the bright color, dim color, I don't know. What else can be? Water, wind, okay? Those are nominal data. Ordinal data, what do we have? Ordinal data, also qualitative data, like prize, the winner, first Olympic champion. Okay, the first prize, second prize, the prize itself. The difference is between nominal and ordinal, although ordinal is qualitative, but you still can count. First prize, second prize, and third prize. The other example of ordinal, just to make it crystal clear, grade. Grade is unique, right? So it is qualitative. You don't count one grade to grade. But at the same time, you can go, it can uniquely be put in order. Grade A, grade B, C, D, right? And they are in order from highest to lowest. So that is going to be ordinal. Interval, that's the word itself tells you about interval. What can be interval measurement? It's a scale. We never have precise measurement. It's about in the interval, right? It's showing, and then another example, conditioner. It also goes by interval, right? And the ratio, when let's say in any kind of sport game, the score, that's a ratio, 5-1, let's say 3-5, yeah? That's a ratio. Now let's figure it out in our case. In a study, the data you collect is weight, excuse me, in gram. How are we gonna figure out weight by if it's excuse me, too much or too little? By ratio, by comparison, right? If standard is given, it's let's say a human in this age, let's say female, it's a normal weight is this much. For men is this much. And comparing to reality, how you compare, it's a ratio. Therefore, in our case, the answer is going to be ratio. Next one, question number 7. In each study, the data collected is what level of measurement? Well, let's do it. So, letter grade A, B, C, D, F. We already know that that's going to be ordinal. They are unique, yet you can count it, right? Temperature we already know. It's going to be interval. I already explained. Number of traffic tickets. Number of traffic tickets is going to be a ratio because you usually you compare to what considered normal is a safe driver. Let's say number of tickets versus aggressive driver. Yes. Next, agreeable rating on strongly disagree, neither disagree nor agree, strongly agree scale. So what is going to be this one? It's this case is going to be ordinal again, right? Because look, each one of them is unique. Disagree, agree, strongly disagree, and so on. But each one of them, if you put on the scale in the order, you see from stronger disagree, it's growing, rising all the way to strongly agree. Therefore, it's gonna be ordinal. Okay. Now, marital status. Marital status, it's gonna be nominal because it's a quality, and there is no any thing to compare or count or anything else. It's a nominal, unique. Question number 2. Are the following variables discrete or continuous? Which variables are discrete? Which ones are continuous? The ones that you can count are discrete. The ones you cannot count are continuous. What you can't count, which ones are continuous? Discrete, everybody knows, everything that you can count. What you can't count, you can count water, you can count, let's say, wind. You can't count, let me see, person's age, right? How are you going to count? You're going to say the 25 in the 3 months and 1 day? We don't do that, right? So it is continuous. The number of cars served at fast food through drive-through, it is discrete, right? The weight of an elephant, weight, it is continuous, obviously. Okay. And that's pretty much it. This is the end of questions for homework 1.1. Okie dokie.